Okay, Unit 3, Polynomials Review. Consider the following polynomial. 4 minus 7ab plus 2a squared b minus b. So we're looking at all the various characteristics, the key characteristics of a polynomial. List all the monomials. So that is all the monomials. 4, negative 7ab, 2a squared b, and negative b. Good. List all the constants, and constants are just numbers without any variables attached. So we have 4. 4 is the only constant. What is the degree of the polynomial? So you have to look at each monomial of the polynomial and find the highest degree monomial, and that is the representative degree of the entire polynomial. So let's find the degree of each monomial. What's the degree of 4? That's 0. The degree of 7ab, the exponents on a and b are 1 and 1, so it's 2. What is the degree of 2a squared b? There's an exponent of 2 and 1, so that's 3. And the exponent on the b is just 1. So the degree of the polynomial is 3. So you take the highest degree of the monomial within the polynomial, so it's 3. What is the leading coefficient? So the leading coefficient is the coefficient on the highest degree term of the polynomial, which is 2a squared b, so the leading coefficient is 2. Alright. Moving on, adding and subtracting polynomials. So we have the situation where we have these brackets. So when you're adding polynomials, x squared plus 4x minus 2 plus, and we come across this bracket, so there's a plus sign, so there's nothing more to do other than just drop the brackets. It doesn't change the value within the brackets, so you can just drop the brackets without changing the signs within. Now we have to look for like terms. This x squared and the 2x squared are like terms, so that's 3x squared. 4x and minus 6x, that's minus 2x, and minus 2 and plus 9, that's plus 7. So we have 3x squared minus 2x plus 7. Another one, simplify. 4y squared minus 2y plus 3 minus the quantity in brackets, 3y squared plus 5y minus 2. This time we have a minus sign across a set of brackets, so watch what we have to do. It will change the value within. So let's rewrite the first part, 4y squared minus 2y plus 3. And distributing this minus sign, it's like multiplying the entire polynomial within the brackets by a negative 1. So let's drop the brackets, but let's apply the negative 1. So negative 3y squared. The negative sign across the plus 5y makes it a 5 minus 5y. And the negative sign across the negative 2 makes it a plus 2. Okay, so you see how the negative sign affects what's inside the brackets. Now all we're left with is combining like terms. That is y squared, and then we have a minus 2y and a minus 5y, that's minus 7y, and plus 2 and plus 3 is plus 5. There you go. Simplify. Negative 7m squared minus 12m minus 4 minus the quantity, negative 2m squared minus 8m minus 5. A bonanza of negative numbers. So let's keep track of this. So let's rewrite the first part. Now applying that negative sign across changes the signs of all the terms within the bracket. So that's plus 2m squared plus 8m and plus 20. Oops, sorry. Plus 5. There we go. Okay? Now that we've done that, let's collect like terms. Negative 7m squared and 2m squared, negative 5m squared, negative 12m, and 8m is minus 4m. Minus 4 and 5 is plus 1. There you go. Multiplying, dividing polynomials. First, let's take care of the power outside, the exponent outside of the bracket. So that's 27x cubed times 4x to the 4th. Okay. and then 27 times 4 is 108, and product rule, x to the 3 plus 4 is x to the 7. Next one, 20 divided by negative 60 is negative 1/3 times x squared minus x is just x. X squared divided by x is just x. And so we're left with negative x over 3. Here we have 10m cubed plus 5m squared plus 15m over 5m. We need to break up this fraction into component parts. And remember, we have a common denominator of 5m. So using your rules of fractions, we can break this up into 10m cubed over 5m plus 5m squared over 5m plus 15m over 5m. And let's divide out the common terms here. 10 divided by 5 is 2. M cubed divided by m is m squared. 5 divided by 5 is 1, so we're left with m squared divided by m is just m. Plus 15 divided by 5 is 3, and m divided by m is just 1, so we're left with 2m squared plus m plus 3. Let's try another one here. So we need to break up this fraction like this. So let's see what this looks like. Okay, so that's what we got, and then divide everything out. That's 2r squared minus 3 divided by 3 is 1, and r cubed divided by r squared is just r, plus 3, and r squared over r squared is just 1. So 2r squared minus r plus 3. Distributive property and polynomial. So remember, whatever's outside the brackets, distribute to each and every term within the brackets. So first one is 6x cubed minus 21x squared y. So let's check that, 21x squared y plus 6x squared. And there we go. This one, don't say 9 minus 2. Remember your BEDMAS rules, right? So we need to distribute across first. Okay, we can't just do 9 minus 2. We have to do the multiplication first. So that's 9 minus, so negative 2 times 3 is negative 6x, and minus 2 times 5, so we're distributing like this, minus 6x minus 10. So this might confuse you a little bit. You can rearrange it like this, 9 minus 10 minus 6x. 9 minus 10 is negative 1, and there we have it. Multiplying binomials. Let's do it in a number of ways here. FOIL method. So first, outside, inside, and last. That is your FOIL. Okay? So multiply the first two terms together. That's 2x times 3x is 6x squared. Outside terms, 2x times 6 is 12x. Inside is 4 times 3x. That is 12x. And the last is 24. Let's collect like terms. 6x squared plus 24x plus 24. There we go. Let's try the same one, box method. So 2x and 4 and 3x. Let me give myself a little bit more room here. 2x and 4 and 3x and 6. That is, let me line this up better so it makes sense. That's 2x and 4. So 2x times 3x is 6x squared. 2x and 6 is 12x. 4 times 3x is 12x. And 4 times 6 is 24. So we're just multiplying these two binomials through a table or a matrix, okay? And then so these four terms, we're just adding them together. So that's 6x squared plus 12x plus 12x plus 24. Collect like terms, that's 6x squared plus 24x plus 24. And you can see these two are the same, okay? Try another example, FOIL method, so that's 6y squared, that's the first. Outside is minus 4y, inside is plus 9y, and last is minus 6. So that's 6y squared, collecting like terms, plus 5y minus 6. Box method, 2y and 3, and 3y, and be careful here, that's a negative 2. What do we got? 6y squared minus 4y, 9y, and minus 6. Let's add all those together. 6y squared. 9y and minus 4y is plus 5y minus 6. And there you go. The same result. Two different methods. Alright, we saw this from our exponents unit on how to do this. Remember, we don't take the 2 and just distribute the exponent across a plus sign, right? Remember, we don't do that. So what do? We look at the rule for what an exponent represents, and it's repeated multiplication. So do exactly as it says. X plus y quantity to the exponent 2, so you're multiplying x plus y by itself. So that's, use the FOIL method, that's x squared plus outside is xy plus inside is xy, last is y squared, collect like terms. These are the like terms here, so let's rewrite it, x squared plus 2xy plus y squared. Okay, this last one, you can, it's not a FOIL method, but we have a binomial and a trinomial. What you can do is set up a box. I think it's a bit easier to keep track of here. Alright, x cubed, 3x squared, and that's minus 4x. That is minus 5x squared minus 15x plus 20. All the 6 terms in the box, let's add them up. X cubed plus 3x squared minus 4x minus 5x squared minus 15x plus 20. Collecting like terms, x cubed, there's a 3x squared and a minus 5x squared, that's a minus 2x squared. There's a minus 4x and a minus 15x, that's a minus 19x plus 20. Alright, everyone's favorite problem. Determine the area of the shaded region. So let's look at a formula overall. We can say area of the shaded region equals area of the big rectangle minus area of the small. So the area of the big rectangle is this big boy right here with sides of 3x plus 2 and sides of 2x plus 5. Area of the small rectangle is this little guy right here where the sides are 2x and x plus 1. Okay? So let's see how we do this problem. So what is the area of a rectangle? So let's start with the area of the big rectangle. We know in general the area of a rectangle equals length times width. Okay, so area of the big rectangle, what's the length and what's the width? The length is 3x plus 2, and the area of the width, the width is 2x plus 5. And now we just have a problem where we're multiplying two binomials, and we know how to do this. Let's do the FOIL method, 6x squared plus 15x plus 4x plus 10. And that's 6x squared plus 19x plus 10. So that's the area of the big rectangle. What's the area of the small rectangle? And again, it's length times width. So look at the small rectangle here. That's 2x times x plus 1, length times width. Okay, this time we're just distributing across one monomial across a binomial, and that is 2x squared plus 2x. Okay, now that we have the area of the big and the area of the small, like we said originally right here, just plug the values into the formula and let us see what we get. Okay, so area of the shaded region equals What's the area of the big rectangle? That's 6x squared plus 19x plus 10 minus the area of the small rectangle minus, and use parentheses, brackets, 2x squared plus 2x, because that's the entire quantity of the area of the small rectangle. Now let's simplify things a bit. 6x squared plus 19x plus 10. That minus sign needs to be distributed across the binomial, so that's minus 2x squared minus 2x. Now we're collecting like terms. like terms, there's a 6x squared and a minus 2x squared, that's 4x squared, plus 19x minus 2x, that's plus 17x, and then we have the 10 by itself. So there we are. The area of the shaded region is 4x squared plus 17x plus 10. Moving on. Factoring. N squared minus n to the fifth. So we are factoring out what's common to both terms. So that's an n squared. That's 1 minus n to the third. You can check it by saying, by looking at distributing it back in, do you get the original term? That's n to the third. Yes, you do. So this is good. Okay. What's the common factor between 3x squared and minus 6? And that would be a 3. So that's x squared minus 2. Here's a nice trinomial. What's common with the three terms in the trinomial? I would say that's 4x squared. So factoring out, we have 3x squared minus 2x plus 1. So you can check it by saying, by multiplying it back through, and you should get the original value. Okay, so you can pause and try that on your own just to check it. This one, the common factors aren't always just monomials, they could be binomials. So here the common factors are x plus 1, so we factor out an x plus 1, and what are we left with? X plus 3. Okay? Here we need to do a bit of grouping, so we do this business right here, so that this first term, we can pull out an x squared, factor out an x squared, that's x plus 1. Here, the common factor is 3, that's x plus 1. We're not done yet. Now we have this x plus 1 and x plus 1, that is a common factor of both terms. So we factor out that x plus 1, and we're left with x squared plus 3. Same deal here. Let's group these as such. So the common factor of these first two terms are 2x squared, that's x minus 3 plus, let's throw a 1 in front of here so we can see this problem a bit better. Now we have the common factors of both terms as x minus 3. Let's factor that out. And we're left with 2x squared plus 1. Number 8, algebra tiles. Remember the bars, this colored bar, the shaded bar, is an x, this is a 1, this is a 1, this is a negative 1. These are negative x, this is 1, and 1. Okay? And then when you say negative x times x, that is negative x squared. So we're going to leave that as an open big square, unshaded. Negative x times 1 is negative 1, so that is a, sorry, negative x times 1 is negative x, so we're going to leave that as an unshaded bar. Negative x times 1 again, the same thing as unshaded bar. Negative x times negative 1 is a 1, so we're going to shade that in. Okay, sorry, negative x times negative 1 is x, so we're going to shade that in, so that's x. Okay, so that's the row, first row there. And this row, it's the same thing, so we're just going to go like this. Okay, it's just the same as the first row, this negative x applied across the top again. This time we have a 1 times an x, so that is an x, which is a shaded bar. 1 times a 1 is a small square shaded in. 1 times a 1 is a small square shaded in. 1 times a -1 is a -1, and that's an open small square. Same thing across, we're just repeating. So there we go. So what we do here now is count up all the tiles and see what polynomial that represents. So this first row, we have -x squared right here. This is -x squared. These two unshaded bars are -2x, and then that shaded bar is plus x. Same thing here, -x squared minus 2x plus x is just the same as the first row. Here we have a shaded bar that is x plus these two small shaded squares is 2, and that's a -1. And we're repeating again, x plus 2 minus 1. And so this one is x squared minus x squared minus x plus 1, x plus 1. Okay, let's add all these up. Let me bring it over here. That's x squared minus x plus x squared minus x plus x plus 1 plus x plus 1. So we're adding up all these terms here. Okay, let's collect like terms. Here's an x squared and x squared. That's 2x squared minus x plus x. Those all cancel out. So there's no x in this term. You can see there's a minus x here, plus x, that's 0. Minus x here, plus x, that's 0. So what are we left with? A 1 and a 1, and that's plus 2. So your algebra tiles represents that polynomial right there. Next page, factoring trinomials. Factor the following expressions completely. So I'll do this with that first method that we learned, just so you have a reminder. So to factor a trinomial, we're going to factor it into its component binomial. So we have to ask the question, what has a product of 6 and a sum, right? So let's look at the things that have a product of 6, and let's find out what the sum is, and let's investigate. So what multiplies to 6? So that's 1 times 6. So the factors of 1 and 6, when you add them, that is 7. What else? 2 times 3, so 2 plus 3 equals 5. So we're doing this thing of what multiplies to this and adds to this, right? So let's build this table. So that is, what other factors? So we have the positive one. So let's do -1 times -6, because that also equals positive 6. So -1 plus -6 is -7. And -2 times -3, -2 plus -3 equals -5. So which ones work here? So I would say it's this one. Because remember, we're looking for what multiplies to 6. So 2 times 3 definitely equals 6. And what adds to 5. So what multiplies to 6 and what adds to 5. So that's the whole game here with factoring trinomials. And it's the factors of 2 and 3. So what we do with the factors of 2 and 3 is x plus 2, x plus 3. So when we expand this, we get x squared plus 2x plus 3x plus 6. That's x squared plus 5x plus 6. So that is correct. Check. Okay. Let's try another one. X squared minus 13x plus 12. So what has a product of 12? And let's investigate. And what's the sum? So let's see which one ends up working out. So we're looking for a product of 12 and a sum of -13. So let's just list all of them. 1 times 12. 1 plus 12 equals 13. 2 times 6. 2 plus 6 equals 8. 3 times 4. 3 plus 4 equals 7. Okay, and I think that's it. 5 and 6, we did that. So let's do the negative ones. -1 times -12. That's -1 plus -12 equals -13. -2 times -6. -2 plus -6 equals -8. And -3 times -4. -3 plus negative 4 equals negative 7. So which one of these works? What multiplies to 12 and adds to negative 13? So which one is it? It's right here. Okay? So how do we build that? That is x, the factors are negative 1 and negative 12. Okay, negative 1 and negative 12, x minus 1 and x minus 12. If we expand that, we get x squared minus 12x minus x plus 12. Collecting like terms, x squared minus 13x plus 12. So that checks. It equals the original. All right. Last one, a little bit of a wrinkle here. So we have 3x squared. Oops, what happened there? All right, let's go here. We have 3x squared minus 6x plus 3. So we need to factor a 3 out first. That's x squared minus 2x plus 1. And so we're going to ask the question, what multiplies to 1 and adds to negative 2? So if you've done enough of these, you can set it up just like this. Okay? What multiplies to 1 and adds to negative 2? So the clue is that it multiplies to a positive number but adds to a negative number. So you know you're going to have two negatives. And what multiplies to 1? Using whole numbers, it's just 1. So that's it. So 3. Let's multiply this out, expand it, and make sure it works. So x squared minus x plus 1. And that is 3 times x squared minus 2x plus 1. And if you distribute that 3, that's 3x squared minus 6x plus 3. And that, in fact, equals our original trinomial. Okay? Here's a whole bunch more, and with enough practice, you should be able to do these by inspection. So what multiplies to negative 15 and adds to 14? So set it up like this. Let's see. So one has to be negative, one has to be positive. So I'm going to say 15 and 1. Multiplies to negative 15, and then 15x minus x is 14, so that works. Next one, let's set it up like this. 1 multiplies to negative 15 and adds to negative 14, so this time it's going to be the other way around, and there you go. What multiplies to 21 and adds to negative 10? So this one should be a clue that there's going to be two minuses, and the factors of 21, if you run through all of them, the one that you should arrive at is 7 and 3. Negative 7 times negative 3 is 21. Negative 7x plus negative 3x is negative 10. So that one works. Next one. What multiplies to 21 and adds to 10, and that's just 7 and 3. What multiplies to negative 30 and adds to positive 7. So if we run through the factors of 33 and 10 are the ones that work. And we need a positive 7, so we're going to use the larger number 10 as the positive and minus 3. So 10 times negative 3 is negative 30. 10x minus 3x is 7x. Good. All right. Last couple here. Let's see. Multiplies to negative 30, adds to negative 7, so it should be like that. Negative 10 times 3 is negative 30. Negative 10x plus 3x is minus 7x. This one, what multiplies to negative 36 and adds to negative 9? What are the factors of 36? Let's see. I think 3 and 12 would work. So we want the higher number, minus 12x plus 9. Oops, not 9. X minus 12x plus 3. Negative 12 times 3 is negative 36. Negative 12x plus 3x is negative 9, so that one works. Okay, hang in there, last one. That's x. What multiplies to negative 36 and adds to 9? That is plus 12 and minus 3. 12 times negative 3 is negative 36. 12x minus 3x is positive 9. Okay? By inspection. Alright, last one. Remember these kinds of problems. What values of k would make the expression x squared minus 7x plus k factorable? So, set it up like your table. Product of k, and the sum this time is negative 7. Okay? What multiplies to k and adds to negative 7? Well, let's investigate. Pick two numbers that add up to negative 7. Let's keep it simple. Negative 1 plus negative 6. That's negative 7. What's negative 1 times negative 6? That is 6. Negative 2. Let's keep going. Negative 2 times negative 5. Negative 2 times negative 5 is 10. Let's keep going. Negative 3 plus negative 4. Negative 3 times negative 4 equals 12. Okay, you get the idea. Okay, you can also do positive numbers. Let's say it's positive 8. Sorry, let's do it this way. There's other factors, numbers that add to negative 7 that don't involve two negative numbers, right? So let's do negative, as an example, negative 8 plus 1. That's negative 7. So negative 8 times 1 equals negative 8. And you can see we can go on down the line. Negative 9 plus 2, that is negative 7. Negative 9 times 2 is negative 18. And you can see that we can just go on forever and ever. Negative 10 plus 3, negative 10 times 3 equals negative 30. Okay? Now that we have this, we look at all the products that result in a k value. Okay? So what that means is that here are all the k values, right? These are all your k values that we just looked at. So let's build possible trinomials that work. That is x squared. Let's do it this way. Since we picked the factors, we said that's a k value of 6 means that the two binomials are x minus 1 times x minus 6, and that equals x squared minus 7x plus 6. So here your k value is 6 right here. Here are all your k values. Okay? And we'll see how the k values match up. Okay, this one, x minus 2, x minus 5. So we're looking at the product of k, right? X minus 2 times x minus 5, and that equals x squared minus 7x plus 10. So you see your k value here is 10, and your k value here is 10. Okay, and so on. X minus 3 times x minus 4, and that equals x squared minus 7x plus 12. Here's the one where it's a negative and a positive value. That's x minus 8 times x plus 1. That equals x squared minus 7x minus 8. And there's your k value of minus 8 and minus 8. X minus 9, and you can see the pattern here. X squared minus 7x minus 18. And so on. X minus 10, x plus 3, x squared minus 7x minus 30. Okay, so here are all your k values, and actually there's more and more k values there. Okay, what values of k would make the expression x squared plus kx minus 9 factorable? So this time the k is in that position. So what has a product of negative 9 and sum of k? So let's build that table. Product of negative 9, that's 1 times negative 9, and 1 plus negative 9 equals negative 8. 3 times negative 3, 3 plus negative 3 equals 0. Let's see, negative 1 times 9, and that's negative 1 plus 9 equals 8. And I think that's it. Yeah, and we're just using whole numbers, okay? So that's what we got. So let's build these equations, or sorry, these trinomials. That's x minus 9. So x minus 9 times x plus 1, and that equals x squared minus 8x minus 9. And so this time, these are your k values. Okay, so let's watch that. Here we have x plus 3 times x minus 3, and that is equal to x squared minus 9. And what we did here is that the k value is 0. So that's actually x squared minus 0x minus 9. Because we said the k here is 0, so here's a 0, and of course that's just that, and it results in x squared minus 9. This one is x minus 1 times x plus 9, and that result is x squared plus 8x minus 9, and you can see the k value here and the k value there. Okay, so those are your possible k values, negative 8, 0, and 8.